Okay, so again, stoichiometry is the use of balanced chemical equations to make predictions about what will happen in a chemical reaction. On the screen, you see a diagram of what's called a down cell. A down cell takes sodium chloride, table salt, and it rips it apart chemically into pure sodium metal and chlorine gas. The cell facilitates a reaction and makes a chemical reaction happen where sodium chloride is separated. And you get molten sodium metal and pure chlorine gas. The reaction is this. NaCl reacts to form sodium and chlorine. Now chlorine is Cl2 because chlorine is one of 7 elements that when it's by itself occurs in pairs. We call it a diatomic element. So we give it a subscript of 2. Now to balance this equation, we have 2 chlorines here and 1 here. So we put a coefficient of 2 in front of the NaCl. And then we have 2 sodiums there. So we need 2 sodiums here to balance it. So we put the coefficient of 2 in front of that second sodium. And what this tells us, the balanced equation, is that for every 2 moles of sodium chloride that we put into the reaction, we're going to get out 2 moles of sodium and 1 mole of chlorine gas, Cl2. Now again, we can use this to make predictions about what will happen. And typically we see 2 types of problems. You have mole to mole, and you have gram to gram. And I'll put gram to gram down here. Now what I mean by that is, for mole to mole, imagine that we have 8 moles of sodium chloride, okay? And we want to know how many moles of chlorine gas we'll get out of the reaction if we put in 8 moles of sodium chloride. So what we'll do here is that we'll put the given amount over 1. And we're going to do this using the factor label method. So again, factor label, the units you're given, you put over 1. Now the idea then is to convert from our given units to our desired units. And as I said a moment ago, our desired units are moles of Cl2. So what we'll do in this next fraction is that we'll put moles of Cl2 over moles of sodium chloride, NaCl, just like that. Now the numbers we're going to put in here, these numbers come from our balanced chemical equation. In this case, we're going to use the coefficients, our molar ratios as we call them. So for chlorine, the coefficient is 1. For sodium chloride, the coefficient is 2. Again, those numbers come from our balanced equation. Now at this point then, we do the math. 8 times 1 is 8 divided by 2. That gives us 4, and that's moles of chlorine. So if we put in 8 moles of sodium chloride, we're going to get out 4 moles of chlorine gas in the reaction. That's a typical mole-to-mole stoichiometry problem. Now for grams to grams, imagine excuse me, that we have 1,000 grams, 1 kilogram, about 2.5 pounds of sodium chloride. And I want to know how many grams of Cl2 we're going to get out of the reaction if we put in 1,000 grams of sodium chloride. So again, factor label method, your given units, your given amount, you'll put over 1,000 grams of sodium chloride. Now in a gram-to-gram stoichiometry problem, our next step will be to convert to moles of the substance that we're starting with. So we're going to go from grams of sodium chloride to moles of sodium chloride. And to do that, you divide by the formula mass. So 1 mole of sodium chloride is 58.44 grams of sodium chloride. Basically, we're dividing this here by the formula mass. Grams of sodium chloride cancel out, and we're left with moles. In our next step, we're going to go from moles of one substance to moles of the other substance, of the chlorine. And again, this is our step where we're going to use the coefficients from our balanced chemical equation. So we want to go from moles of NaCl to moles of chlorine. So again, we're going to use the coefficients from the balanced equation. 1 mole of chlorine and 2 moles of NaCl, 1 over 2. So moles of sodium chloride cancel out, and now we're left with moles of chlorine. Final step then, we want to know how many grams of chlorine we're going to get out of this reaction. So I need to multiply by chlorine's formula mass. 1 mole of chlorine, and this cancels out moles of chlorine, is equal to 70.9 grams of Cl2. Now you might wonder, well, wait a minute, chlorine's average atomic mass is 35.45. It is. But remember, in this reaction, it's not simply Cl, it's Cl2. So the formula mass for chlorine for Cl2 is 35.45 times 2. That gives us 70.9. That's your problem. Grams to grams, grams of sodium chloride to grams of chlorine gas. So now you do math, 1,000 times 70.9 divided by the product of 2 times 58.44. When you do that, you get 606.6 grams of chlorine gas. So again, what we're saying there is that if you put in 1,000 grams of sodium chloride, about 2.5 pounds, you're going to get out of that reaction about 600 grams of chlorine gas. That's your prediction, and that's stoichiometry, using balanced equations to make predictions about what should happen in a chemical reaction. Okay?